Early spectrographs from the Atlas SpecLab group reported something that set off alarms: a body dominated by nickel, with virtually no iron in the mix. That runs counter to everything known about comets, which almost always show iron-nickel blends in their vapor. The claim was so unexpected, some labs immediately called for the data to be rechecked. A calibration controversy that spilled onto astronomy forums and triggered a wave of independent reviews. The debate only intensified with the next round of measurements. Instead of the classic water vapor signature, 3I/Atlas's Coma pumped out carbon dioxide at rates 5 times higher than water. The 4.3 micron CO2 line dominated every spectrum, while H2O barely registered above the noise. What couldn't be explained away so easily was the behavior of the tail. Observers tracking Atlas's motion noticed a pattern: 3 distinct accelerations, each spaced about 2 weeks apart, each coinciding with a sharp change in tail color. The first pulse was logged on July 29th, the second on August 14th. Photometric data showed a sudden jump in brightness, while the spectral slope shifted from reddish to nearly neutral, then back again. These so-called Delta 5 pulses weren't smooth, like the gradual push from solar heating. They came on fast, then faded, as if the object had fired a thruster. But the Atlas SpecLab team defended their findings, arguing that the timing and magnitude of the pulses matched up across independent observatories, from the Ibero Tracker Network to Bill Gray's Distributed Telescope Array. The numbers didn't behave like typical outgassing. The tail's CO2 mix seemed to modulate in sync with each acceleration, a phenomenon some called thrust mix modulation. What really set the rumor mill spinning was the energy estimate. If the observed accelerations were real, the implied power source inside Atlas would need to deliver something on the order of 10 gigawatts, about the output of 10 large nuclear plants. That's far beyond what any known comet nucleus can muster. The mainstream view still holds that natural processes can account for most of the data, but the gaps, especially the nickel-only spectrum and the stepwise accelerations, have kept the engineered object hypothesis alive. For now, the Atlas anomaly file remains open, with each new dataset fueling both skepticism and speculation.